This is Geometry, Unit 7. We're going to solve right triangles. This is day number 2. To solve a right triangle, okay, we call it solving. It's necessary to find the measure of all the angles and the side lengths, and the length of all the sides. So we know what one side is, and we're looking for the other two sides. We know what two angles are, and we're looking for the third angle. It's pretty easy to calculate a single angle because the acute angles of a right triangle are complementary. So 90 minus 57 is going to be 33. So that's 33 degrees is our angle C. And we could write that answer right in there and circle your answer. Helps remind you that you now know all three angles. I would suggest to go from the 57, that's the measurement you know. So from this point of view, the opposite, the adjacent, and the hypotenuse. We always want to label our sides. So if I'm going to solve for AB, AB is the adjacent side. We know the opposite side. So looking at SOHCAHTOA, we know that we're going to be using opposite and adjacent. So that's tangent. So tangent of 57 is going to equal the opposite side over the adjacent side. We're calling that AB. To solve, we can turn this into a proportion by placing it over 1. Now we can cross multiply. AB times the tangent of 57 equals 14. We're going to divide by the tangent of 57. And that gets us AB all by itself. Now, when we use our calculator, we want to be sure that we are in degree mode. You would need to go to mode on a graphing calculator. You want to go down to the third row. Notice you have the word radian. That's a different language for an angle. And we arrow over to degree, and that's where you want to be sure it's highlighted. A good way to test to see if your calculator is in degree mode is sine of 30. Sine of 30 should always give you 0.5. If you're in a different mode, like radian mode, and you did sine of 30, you would get a totally different answer. Sometimes they even come up negative. If you get negative answers, you know you're in the wrong mode. So we want to be in the correct mode, and we want to test our sine of 30, and that needs to be 0.5. So yes, we're in the correct mode. So now we're going to do 14 divided by tangent of 57. 9.09. Next, we're going to solve for BC. You could use Pythagorean theorem now, but we can also use trigonometry. So BC is the hypotenuse. So let's use sine of 57. That equals the opposite side over the hypotenuse. Place it over 1 and cross multiply. BC times the sine of 57 equals 14 times 1. We divide by the sine of 57. So BC using our calculator, 14 divided by the sine of 57 is going to be 1669. We're coming down here next, and we're going to look for the measure of angle A. The measure of angle A, the sine of A, has a ratio of 0.36. We don't know what angle gives us this 0.36. You can consider that opposite over hypotenuse, and this is in decimal form. But we're still going to do sine inverse of 0.36 equals the measurement of angle A. So to switch the ratio and the angle, we have to use inverse. We go to our calculator, we hit second sine, so it says the -1, sine inverse of 0.36. We get 2110. You should definitely be following along with your calculator. Do you know how to type these in? Do you know how to get inverse? Now they're talking about the tangent of A has this ratio. So tangent inverse of 0.8 equals the measurement of angle A. That gives us 3866. And our last one, cosine inverse of 0.35 equals the measurement of angle A. Cosine inverse of 0.35 gives us 6951. So we have 3 different angle measurements. So that's just practicing hitting the inverse button on your calculator, understanding that you still have your typical format of the sine of an angle equals opposite over hypotenuse, which they've turned into a decimal. To solve for the angle, you're going to need to use inverse. Number 5. Here's a group of square tiles, just like the ones on our floor. And we want to know the distance along the diagonal of 4 of those. If these are truly squares, then we have 8.5 for every one of the sides. We have right angles for every one of the angles, because these are squares. Since the 2 sides are the same, we know that these are all 45, 45, 90 triangles. So one way we could solve it is to use Pythagorean theorem. 8.5 squared plus 8.5 squared equals the hypotenuse squared. That's one way to have done it. Would work out great. The other way, we can use special right triangles. This is the 45, 45, 90 rule. Hypotenuse equals the leg times root 2. So we're going to figure out the hypotenuse equals the leg times the square root of 2. So this is 8.5 root 2. That means every one of these is 8.5 root 2. So we're going to have 4 times 8.5 root 2. I know that 2 times 8.5, 2 times 8 is 16, and another half and half gives me 17. And do that another 2 times. That's going to give me 34 root 2. That's the exact answer. And if you wanted to know the decimal version of that, 34 root 2 is approximately 4808. So you could have taken 8.5 root 2 and times that by 4. That would have gotten you the same answer. That's the distance across 4 square tiles. If each side of the square tile was 8.5. Last one. We have a similar one that we've talked about in the past where you have a hot air balloon. We're looking for the distance from B to underneath the hot air balloon. If the angle of depression to person B is 42 degrees, that is 42. That means the acute angle, the alternate interior angle, is also going to be 42. We want to know how far is the person from below the hot air balloon. We want to know that distance. So if I was to redraw this, I have 42, I have 600, and I have my unknown. From the 42, this is my opposite side, this is my adjacent side. So SOHCAHTOA tells me I'm going to use tangent of 42 equals opposite over adjacent. I'm not going to use inverse here because I already know the angle. Cross multiply to solve. So x times the tangent of 42 equals 600. We're going to divide by the tangent of 42, just like we have so many times before. We're going to do 600 divided by the tangent of 42. 666.37. That's the distance from B to underneath the balloon.